Hey folks, so in this video, let's take a look at the basic implementation of a stack. This is effectively going to be putting together everything we've talked about in the past couple of videos. So you'll see the source code on the right hand side. So this is our class, and it's called Fixed Capacity String Stack, which is a really long name, but I was trying to get in there all the limitations, right? It's fixed capacity, it's only strings, right? It's pretty limited. So we're going to start with this. So let's take a look inside. How does this thing work? We have two variables inside. One is data, the other is n. So data is an array containing my pieces of data, right? So it's an array because obviously I'm going to have multiple things in my stack. And we said, oh, hey, this stack is just going to store strings, so it's a string type as well. So that's called data, right? So that's where all my key stuff is going to be. Next, I have a variable called n, right? Which is what we've been talking about. It's our little pointer to indicate how much in that array we've used up. And notice here that I'm setting equal to 0 because I'm using it for the first time, right? Basically, it's the initialization value, right? I'm going to start at 0. I can do it in the constructor too, but just to make this code a little bit shorter, I put it as kind of in the variable instantiation. All right, so those are our two variables we're going to have. The next thing we have here, right, is the constructor, because obviously if I want to actually create an object, I need to have a way to build it. I need to have a constructor. So that's my next thing, a constructor. Now my constructor here has a little bit of a limitation in that it basically asks for the capacity. So what is the max capacity? How many things do you expect to store in the stack, right? That's the question it needs you to answer. It needs you to answer that so that it can actually create a stack of the appropriate size, right? So I give it a number, right? I say, okay, this is a stack of size 100, and it takes that and it uses that to construct an appropriately sized array, right? So here you can see it does equal new string of cap. Basically what we're doing, right, is we're creating a new array, right, of that capacity, right? And that's going to be where I store all my data. Okay, so right now I basically just created an array. What do I do next? Well, now we got some functions to implement. First thing is empty. Is empty though? Pretty straightforward. If n is equal to 0, that means I'm pointing at the bottom. I'm not storing anything, right? So that's going to be true, right? And you can see that I'm returning this directly, right? So if n equals 0, right, it'll be true, right? I don't even have to have an if statement in there. I just directly return the expression. It'll give me true or false, depending on whether or not that matches up. All right, for push, right, now we have something a little bit more complicated. We're doing this. Data of n ++ equal item. Okay, and there's actually a little call here in my slides with a question mark about this too. So somehow, right, there's a sense that when I implement push, I need to update my array, and I need to change n. I need to do two things. So how can I do two things in one line? Well, what I've written here, right, is data of n ++ equal item. Initially, think about that as being data of n equal item. That should make sense, right? Data of n equal item. That'll add my new thing, right? This is push I'm adding. That'll add my new thing to that top position, right? We already said the n would be the index that's empty. It's the place that I want to add things. So that's where I'll put my brand new item. So all of that seems pretty good. Okay, so that's all well and good there. What about changing n? Well, that's what this does. So this is what we call a post increment, right? So there's pre-increment, post-increment. Pre-increment means, well, pre-increment is what you guys may have done before. Post-increment is maybe a little bit foreign. The idea basically is that the ++ only goes off or only happens after you've used it, right? So this line written here, data of n ++, basically I'll store item into data of n. Once the line is done, then the increment will take place and then the ++ will go off, right? So it's actually doing it after this line is done. This code here is pretty much just the equivalent of doing the following. I could remove that and do n ++ afterwards, right? That would be the same, okay? But here it's just to make it simpler so that we know, so that we have less code to put on the slide, basically. So that's push. All right, pop. How does pop work? So pop basically, right, is similar. You're doing a return of minus of n, okay? So the minus is a pre-increment here. That means it goes off before we use n, right? So n is pointing at something, right? So imagine just looking at one element. You do the minus, that means you're pulling it back, right? So now it's looking at the previous thing, which is what we want, right? Because n by itself is pointing at the next available slot. That means if we're doing a pop, we want to take off the topmost thing. The topmost thing is actually one space under n. So if we do minus n, we're going to pull ourselves back to be one previous thing, right? So that'll actually make us look at the new thing, right? Or the thing we want, right? And then we return data of that now decrement n value, which gives me that topmost thing, right? And also because I did the minus n is going to be one less, right? So n went down, right? That means basically that number we're using also for the size of the thing went down as well, right? So it kind of does the same thing of basically returning it in one pass, right? In one go, this line returns us that most recently added element, as well as saying, oh, this is now one smaller, you should now use this slot instead, right? So it does everything at once. The last thing we have here, and it's not on the slide, is size. So real quick, think to yourself, how could you implement size? What would you need to add? While implementing size is pretty straightforward, all you would have is something like probably, well, I can do it really quick. You'd probably have something like a public int size, which returns n, right? That would be our basic implementation. Those are curly braces, honest. Those are curly braces. So that would be the simplest thing to do, right? Public int size, return n, right? And that'll give you your size implementation. All right, so that's our basic implementation of a stack. Very, very limited, but something to start with, right? In the future, we can look at this again and try to make improvements.